Autonomous Vehicle Science Lecture Series, Number 9. Human Mode Motion and its Reproduction, from MotionLab. In this push motion creation, Daniel stands in front of the Swan vehicle to control its motion. As he moves forward, the vehicle backs up to avoid a crash. He also can steer the vehicle by the leg movement he takes. The vehicle uses the direction-tracking motion in the entire motion. While executing push motion, the vehicle saves a motion record at every motion sampling cycle. In the end of this motion, the Swan vehicle output a motion file, the set of all motion records in the vehicle's spell. Daniel is the CEO's old grandson, 4 years old then. Now the vehicle outputs the motion file, which contains all the information needed to reproduce the previous push motion. The vehicle reproduces the same push motion using the motion file. The reproduced motion is precise. In this pull motion, the CEO's other grandson Andrew stands in front of the Swan vehicle, which follows him as he moves back. Swan again uses the direction-tracking GM to produce this pull motion. The vehicle's tracking behavior is robust in the sense that once it catches the person's legs, it rarely loses them. At the end of pull, the vehicle output the motion file preparing the next motion reproduction. Playback of pull under table motion. Now the vehicle reproduces the previous pull motion. Again, Swan precisely reproduced the same motion. In the reproduction, the vehicle uses not only the old motion command, kappa, v, but its frame, x, y, theta, as well. That means the reproduction adopts positional data as well as incremental motion data. Reproducing spatial aspects of the vehicle is more important than its temporal aspects. Andrew executes a push-pull motion, which is a composite motion of push and pull in the next slide. Again, the motion file is output, which reproduces the same motion. The vehicle uses the curvature mode motion in the last three man-made motions. Playback of push-pull motion. The previous push-pull motion is reproduced. To reproduce the push-pull motion, the motion file must include the vehicle's moving orientation, forward or backward. Furthermore, the file has to keep the positional information of switching points. Spatial information is more important than temporal data in motion reproduction execution. Man-made motion in the Omega mode. Swan follows Corey's hand and playbacks backward. The CEO's daughter Corey produces Swan vehicle's motion in the Omega mode by her hand's movement. When she removes her hand, the vehicle stops. The vehicle starts reproducing the same motion backward. Applications of man-made motion and its reproduction. A 5-year-old adorable kimono-clad girl could push a big SUV into a garage and pull from it safely in a private property. The vehicle reproduces the same motion. When a firm posts a video on YouTube, your firm's car will impress millions of viewers. A single driver can lead an entire convoy as follows. A human driver operates the first car and keeps outputting partial motion files. Other cars get partial files to reproduce the master motion. We deliver the best motion creation capacity for self-driving cars. MotionLab possesses sensor-independent and vehicle hardware-independent motion creation technology for self-driving cars. If your company is interested in our licensing offer of the MathMind technology, please visit our site motionlab.info with DreamCar as the password and click the Contact button.